Let's talk about pop object. I want to make some changes over here. Let's delete. We don't need these. And I want to add this bit in the air because we will check collision as well now. First frame. And let's add gravity. So here I can use this -9, or I can disable this and I have one more extra option which is gravity force. So this is also better. So let's go with this one. And I have deleted everything, so I want to use set everything, and let's add this 5, and I want up direction also, and let's just reset everything. Keep 5000. Yep, that's fine. Cool. Increase this. Most useful tab over here is physicals, but before that let's just check out some parameters over here. And at the moment we are using this pop source. For now let me just disable it, and if I just directly use this copy and paste over here initial geometry, it will just create that geometry over here. And if I scatter some particles and if I use these, I can just set, right? So here we have gravity, that's why it's working. So this is to set initial geometry if you don't want to use pop source, but it will emit on creation frame only. But if you keep these creation frame $F, meaning current frame number, so it will emit per frame. Best way to use this pop source only for emission, and I don't want to use this. Cool, we understood initial geometry, and here we have collision also. To check this we need collision. Let's start with crown. And how do we connect these? We have to use merge. Here it's written left input effect, right input. Let's connect this to check it. And yep, now it's working. And here we have option mutual also, so it doesn't matter where it's connected, but it's better to use these for better organization. Yep, it's working. And let's just go to front over here. Let's just fix those stepping for now. So to fix this over here also, and let's just use positive forward, right? So it will fix over here as well. Yep. So tolerance is not so useful. Useful parameter is volume offset. If I increase this, it will create a gap over here. You can see it's created 1 meter gap. Check these. Yeah. And if I increase tolerance or something, there is no difference. Right, so everything is it's same only. Yep. So next let's talk about this physics. Most useful parameter over here is 2, bounce and friction only. Let's explore others as well. So this controls the bounce overall. If I But here if you have noticed, that technically it should bounce and go this way, right, in this direction. So if I increase this bounce forward, will it solve the issue? Let's just check that. No, it won't. Why bounce forward is not working? Let me just reset for now. Let's just draw something. So at the moment, if you notice, it goes this and it's making this moment. what we need, it should go this way and it should make this moment. Why it's not happening? Because of friction. If object is not rotating on the surface, it won't slide, meaning it freezes its rotation, so it will go a direction. But if it rotates, then it will go in this direction. Let me just show you. Rotation I have mentioned for understanding only, but majorly it's using friction, so it will slide, right? So let's just reduce this friction. Yep. So now if I increase bounce forward, it will move in this direction more, right? And there are two types of bounce. So this controls the bounce forward and this is just bounce. So if I increase this, it will bounce in up direction. See? So these are the options. Yep, it will work in. And similar parameters we have over here as well, friction and bounce and everything. And we have dynamic friction also, which controls the scale overall. So if you reduce this, it will slide more. See? So here majorly you will be touching friction, bounce, and temperature is not useful for now. Yeah, here. Next I will talk about collisions. Cool, let's talk about collision. So here let's understand, does particle collide with each other? So no, it's too tiny, so it doesn't collide. But if you want to add particle collision, then you have to set p scale. P scale we will talk about when we render this. But for now, let's just understand. So you can just set a p scale, basically radius of the particles. And after that, you can run a grain solver, so it will collide each other. And also, if you want to add collision, it will increase 5 times or 10 times simulation time also. Yep. So this particle collide with an object. Let's add collision object now. So we need box over here. Let's select this template. Yep, that's fine. So how do we read this? We have to use static object over here. If I check static object, I have some options over here. Object name is this thing, so I can just name it box. And second thing is SOP path. We need SOP path over here. Yeah. So it's not visible at the moment, so you can just connect this over here. So now it's visible. Let's run the simulation. It won't collide because here it's following this rule, right? So here we can just add merge and end over here, or else you can just use this also, but it will be too complicated, right? You cannot just merge multiple over here. Can you see it's colliding now? But best way is this merge collision. Let's disconnect this and connect over here. If you have multiple collisions, you can just merge over here. And now let's just check. So it's working now. Let's study some parameters over here. So first step, we have physical, which we already studied, and we have some other parameters also over here. Object transfer, create active and everything. Let's just check some of them. I will explain use deforming later, but first let's understand what is use object transform. So it's just if I use box over here, right, and I will just transfer at object level, and I'll just copy this and paste over here. As you can see, it's right there. If I turn on object transfer, it will follow that whatever we have over here. Let me delete this. paste over here. So we don't want to use this. And what is active object? An active object, it won't do anything. We have to use rigid body dynamics. Let me connect these. And here it won't work because it's set to bullet and we have to use RBD over here. So I will just explain this also in some time. Now you can see. Yeah, that's just brief. And ignore merge relationship is just collisions. So it won't collide. So whatever connection we have over here, it won't work. Great. So now let's talk about deforming. So let's add some deformation over here. It's static at the moment. So I can just type $f multiply by 3. So I want to use current frame and I want to multiply by 3. So it will rotate faster. Let's just check. So as you can see, it's not rotating. I can just turn this on and let's check output. So as you can see, it's a collision issue, right? So you can see some stepping, some gaps over here. And how do we fix it? First, let's understand reason behind it. So in this case, we need in between frame data. For example, first frame, second frame and third frame. At the moment, simulation is running this way, right? If object is rotating this way, right? And this is second frame, right? So I want information in this area also. So we have to run this in between frames this way. And here we have to use substeps. So let's just set substeps. If I increase substeps, will it fix? Let's just check it. So it's not fixing that much. And here, let's just check second parameter also. It mentioned that it will solve in between data also, meaning it will just interpolate geometry. So let's just check, will this work or not? I'll just stay on this frame. Let me just reset. No, there is no difference. This option is not useful in this case. So now what to do? Here we have to check this. Let's just select this over here. And if I go and disable this integer frame, then I have in between frame data. So if I run, you can see it's not moving in between frames. Why? Because I'm using $f. So I need floating frame. So I can just type $ff over here. And if I run, you can see I have smooth movement. And now let's just check. So I'll just stay on the frame. I have two substeps. Let's just reset. Yep, it's solving that issue. So that's what you need to understand over here. This is how it works. And the more substeps you increase, the more it will fix these things. And now let's talk about this collision tabs. So this is most useful over here and you will have to always check this thing. So if I scroll down, I have some parameter over here and I'll just ignore everything and just click this guide geometry. And let me just disable this over here. So this is what basically a collision. So you have to always check this. And if you have any open polygon, let me just delete. Right, so I have this open polygon. You can check this, change the shape also now. Right, see. So if you have points over here, it will just bounce. And if you have open polygons, just always use polyfill. And make sure you always send a watertight mesh. So you won't have any glitch. Let me delete everything. So let me just disable this. I don't want in between frames. Here, have you noticed something that it's creating this mesh every frame and it's kind of jittery sometimes. And what's happening over here, it's using this mode ray intersect, and if you want to increase the resolution, you can just go and increase over here. And there are other options over here as well, but those are not useful. Just you can use these, but it will affect simulation time also. And if you keep this visualization on, it will take more time. If you turn this off and turn on this, then it will take lesser time. It's creating volume on every frame. That is also one reason it's creating those gaps. And in fact, we can fix that without substeps also. So I have talked about this volume, and next step we have surface as well. And let me just turn this off, and you can see it's clean geometry. It's not a volume. And this is exact surface. Whatever we are providing it, it will use that. And let me check. Does it fix that issue? Let's reset everything. So we don't have substeps. So it's not. So here we need to understand, if we turn this on, it won't utilize this surface option. So we have to use surface collision now. And I will just stay on this frame and I will just reset this. So you can just immediately see the difference. Yeah, it's fixing it without substeps, and it's too fast. We are using very simple geometry collision, right? But if you have complex geometry, in that case, it's very expensive and it may crash your simulation also sometimes. So still you can optimize your geometry and use this option. But I will recommend you to use this volume, but not ray trace. You have other option, volume sample. And there are other options as well, but those are not so useful. You can just use volume sample, that's most recommended. And let me just reset everything. And how to use this over here. So if you use this, we have one more parameter over here. Let me just reset. You have parameter over here, proxy volume, and let's just use that. So here I'll just use collision source. First input is this, proxy volume, and you can see we have some volume over here, and you can control this in second tab, collision. So this is the voxel, and you can even create this also. It's just VDB from polygons. It's same only. Benefit of this node, it will calculate in between frames and it will add velocity also. So it's better to use this. And let me just copy and paste over here. Cool. So I'm using this volume collision, and let me turn on collision guide. So at the moment it's using ray intersect. Let me use volume sample now. Yep. And I have to turn this off visualization in order to run faster. And we know how to fix it. If you have clean geometry, you can just switch to this use surface collision. But if you have complex geometry, in that case you can just increase substeps. So in this kind of case, it makes using substeps. But don't use substeps to fix those stepping created by moving source. So I have created a tutorial on YouTube. You can check that later. And substeps also helps to calculate extra moment in short frame. It can be useful for curve motion blur. And let me just show you what this parameter. So this parameter is not so useful. If I turn this on, it stays the same. Yep. So yep, I will recommend you to check all the steps and everything, and you can just increase this 4, so it will fix it. Yeah. So whenever you increase sub steps, it will increase simulation time also. Yeah. So now it's fixed. Cool. Let me reset everything now. And we understood this volume and difference between volume and surface. You can utilize in some cases, and you can utilize this also in those heavy geometry cases. And second tab over here is bullet data. So you have to remember that if you are using particles or flip, it will use this RBD solver. But if you are using rigid body solver, remember we have used this. If it's set to this bullet, it will utilize this collision, and if you use this RBD, it will utilize this thing over here. So in particle, it's not useful. And next, let's talk about pop solver.